So first, when you take notes, you write a title. Add, subtract, multiply polynomials. Did you notice the word divide is not there? Dividing is a little bit more difficult, and it's going to take a whole special section. So we are not dividing polynomials at this time. So my first question is, do you know what a polynomial is? A polynomial is a function that can be written in this form. That's an a little n x raised to the n plus a to the n minus 1 x raised to the n minus 1 dot 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 a to the 0 power x plus c. What in the world does that mean? Well, first of all, it means that we're not going to have any square roots. We're not going to have any x's in the denominator. We're not going to have any x's to the power of a fraction. A polynomial might look something like this. And so you see that the variable is x, and do you see that the powers are going down? A power of 4, a power of 3, a power of 2, a power of 1, plus a number that doesn't have a power. And it doesn't have an x. That's what a polynomial is. This one has 1, 2, 3, 4, 5 terms. These are called terms. So this is a polynomial. Notice that we have x squared, and then we have x without a power, and then the last term is a constant. It doesn't have any x at all. This has 1, 2, 3 terms. If it has 3 terms, it is a polynomial, but it is also a trinomial because it has 3 parts. Tri is the prefix for 3. Or we can have a polynomial now this has an x squared, but it doesn't have an x at all. That's okay. How many parts does it have? It has 2 parts, so it's called a binomial. And when we have polynomials, we add polynomials by combining like terms. What's a like term? Like terms have the same variable and that variable has to have with the same exponent. It's a like term if it has the same variable. What's another word for variable? Letter. Has the same letter with the same exponent. Do I need to wait a minute? Raise your hand if you need me to wait a minute. So if I have an x squared plus another x squared, that makes 2x squareds. The variable stays the same, the exponent stays the same. If I have 7a to the third power plus b to the third power minus 2a to the third power, I'm looking for the same letter with the same exponent. If you have a highlighter, that helps you sometimes find the ones that go together. So, are those like terms? Do they have the same letter and the same exponent? So you combine like terms by adding 7 plus a negative 2. Does this one have a like term to go with it? So it just has to move to the answer. Doesn't have anything to combine. (10b to the third power minus 7b squared). Does that have a like term? Does it have it has the same letter, b. Do they have the same exponent? They are not like terms because they have different exponents. I can't do anything with that. That's it. I cannot, I should rephrase that because we are going to learn something you could do with that. But you cannot combine those terms because they're not like terms. Example number 4. A squared b plus ab squared. They both have an a and a b. They both have a squared. But are they like terms? No. This one has an a squared and that one doesn't have a squared. This one has a b and that one has a... There's nothing I can do there. I cannot combine those because they are not like terms. 4m to the fourth power plus 5n squared minus 6m to the fourth power plus 7n squared. Now, if you don't have a highlighter, you might just underline the ones that go together. This one has an m to the fourth power, and this one has an m to the fourth power. And the answer will have an m to the fourth power. 4 plus a negative 6 would be a negative 2. And this one and this one have like terms. They both have an n squared. So a 5 plus a 7 makes a 12. And it is considered better form to put, when you have more than one variable, I have an m and I have an n, put those in alphabetical order is considered to be better form. 18x to the third power plus 4y to the third power minus 7y to the third power everything's to the third power, does that mean I can add it all together? This one adds to this one because they both have x to the third power, and my answer will have x to the third power. 18 plus a negative 6 is 12. If you do not know how to add positive and negative numbers, that would be something that you would need to come to tutoring class about, because we are going to combine those. That's going to have a y to the third power. If you don't know how to combine a positive 4 and a negative 7, that's something that you need to work on outside of class time, maybe in tutoring time. When you write it down, it's considered to be better form if it's in alphabetical order, the x part before the y part. 7. 3e to the 5th power minus 4f to the 3rd power minus 6e to the 7th power. Does this e and that e combine? No. And so this one would come first. It is considered to be in better form if the highest exponent comes first. Is the exponent of 7 higher than the exponent of 5? I'm not looking at these numbers in front, I'm looking at the exponents. By the way, do you know that this number in front of an exponent is called a coefficient? The number in front of an exponent is called a coefficient. Is this term and this term like terms? They have f to the 3rd power, and a negative 4 plus a negative 2 would be a negative 6. To add polynomials, you combine like terms. Sometimes they're grouped with parentheses to show this is one polynomial added to another polynomial. So if it has parentheses and it's an adding problem, you just drop the parentheses, because what you care about is combining. I think I put in some extra letters last class period. Combining like terms. For subtracting polynomials. Oops, I went off the bottom. To subtract polynomials, you distribute the negative. Do you know what it means when I put it in all caps? It's important, but I'm yelling at you. Distribute and red means I'm yelling at you really loud. Did you know that if you put an email in all caps that you're yelling? And if you put it in all caps in red, you're yelling really, really loud. I didn't know that 20 years ago when I was doing emails, when it first got to be a big thing, and I sent an email to the principal in all caps and red. It was just like stuck on there, and I got in trouble because was yelling at the principal. So, capital means you're yelling. Red capitals means you're yelling really loud. So, and I'm yelling at you because this is important. Distribute the negative. Then we're going to drop the parentheses. And then we're going to combine like terms. Are these last two steps the same as adding? So once you distribute the negative, then it's the same as an adding problem. I'm waiting a minute for people that are writing the steps. If you did not get the steps, you can go back and look at the video. So if I have 3a squared plus 3ab minus b squared added to another polynomial that has 4ab plus 6b squared. The parentheses are grouping one polynomial and another polynomial, but to add them, I need to combine like terms, so I don't need the parentheses. Just drop the parentheses and then combine like terms. Do I have another a squared term? A is, of course, the first letter in the alphabet, so it would have to come first. This one has an a. It has a smaller power than a squared, so it's going to come next. Do I have another one that's going to go with this one? And the answer is also going to have an ab in it, and 3 plus 4 would be. And then this one has a b squared, and this one has a b squared. This one doesn't have a number in front of it. So that means that I have one of those. And I most often go ahead and write the one in so I don't forget about the one. So I have a minus 1 and a plus 6. So that is the polynomial added together. Now, I rewrote this so that you can see that I'm dropping out the parentheses. You can also just ignore the parentheses and not rewrite it if it is an adding problem. If it is a subtraction problem, you cannot ignore the parentheses. Because what do you have to do first? Distribute the negative. The negative is like having a negative 1 right here. You have to multiply the negative 1 by all of those terms. Negative times negative makes a positive. Negative times positive makes a negative. Distribute the negative, drop the parentheses, combine like terms. This one has a y squared, this one has a y squared. So the answer has a y squared. 5 plus a negative 2. This one has a y, this one has a y, the answer has a y. 7 plus 4. This one is a constant. It doesn't have a variable at all. This one is a constant. 8 plus a negative 3. When you write your answer, it should be in this form with the y squared before the y and the one without a variable last. That's called a constant. Four a squared minus 6a plus 7 minus 2a squared plus 12a minus 15. So, what I need to do first, since this is a subtraction problem, I need to distribute the negative. Negative 1 times 2, negative 1 times 12, negative 1 times negative 15, negative times negative makes a positive. Drop the parentheses, combine like terms. This term and this term are alike. They are a squared. 4 plus a negative 2. This term and this term are alike. Negative 6 plus a negative 12. This term and this term are alike. When you put your answer, you're going to do these problems, and when you put an answer like this in the computer, the a squared needs to come first, and then the a and the number without an a. And so you would type this into the computer, 2a raised to the second power minus 18a plus 22. That's what it would look like when you type the answer into the computer and you find this symbol right here, shift 6. Problem number 11 is 2x squared minus 17x minus 22 plus 5x squared minus 4x plus 9, and if there's parentheses around it, drop them or ignore them. I usually don't go through the step of rewriting it. Now, I can ignore them because this is an addition problem. So, I combine like terms. 2x squared plus 5x squared makes 7x squareds. This one combines with that one for a minus 21x. And these are like terms. They don't have any constant. They are constants. And so, what would that be equal to? Now, before I do the next example, are you still writing on this one? I have a question for you. If you don't have to write this one down, just look at this one. If I told you that the perimeter of this triangle was 40, and I told you this side was 10 and this side was 12, what would you do to find the missing side? Add what? Add the 10 plus the 12, and does that mean the side is 22? No, then what would you do? Is that very clear? Anybody confused about that? Because we are going to do the same problem with polynomials. Instead of having numbers, I'm going to tell you that the perimeter of the triangle is this polynomial. By the way, let me remind you from geometry, perimeter means add up all the sides. And the sides of this triangle are polynomials. So just like we did before, we're going to add up the two sides we know and subtract it from the total. So just like my previous example where I had numbers, I'm going to add together the two sides that I already know. Only I'm not going to get a number, I'm going to get a polynomial. When you're adding, the parentheses really have no effect, so I'm going to add my x squareds together. I'm going to remember if there's no coefficient, the coefficient is 1, and I usually write that in so I don't forget about it. So this is going to be 2 plus 1. And then I'm going to combine 3x and another 3x. And then I'm going to combine 6 and negative 5. That's the two sides added together. To find the missing side, I'm going to take the total and subtract the two sides added together. To subtract, you distribute a negative 1. So that's going to be minus 3x squared minus 6x minus 1. Now, when I did this problem in a previous class period, I kind of didn't leave myself enough space and I crammed it all together, and then I couldn't tell what the like terms were because it's all crammed together. So I would encourage you to write neatly so that you can read what you're writing. So this is a like term and this is a like term. 4 subtract 3 would be 1x squared. This is a like term and this is a like term. 5 subtract 6 would be a negative 1x squared. 5 subtract 1 would be a 4. Now, that's not considered good form. 1x squared is just x squared. 1x is just x. So that would be considered good form, and you would type this in your computer when you get this problem, or problem. If this was the answer to a homework problem, that's how you would type it into Schoology. Now, we don't normally have quite this many examples on your notes, but we do have 4 more examples because we also need to multiply polynomials. When you multiply polynomials, I need to multiply the whole numbers together. I need to multiply the variables that are the same together. This x multiplies by that x. And I need to multiply the y's together. So that would be 5 times 10. X times another x, do you know that that's x squared? And y times another y is y squared. Okay, we're almost done. 2 gets multiplied by the 12. You multiply your numbers together. That has an a. Is there any other a to multiply together with that a? That's the only a. That's the only b. And this c needs to multiply by the next c. 2 times 12 is 24. A, B, C squared. I forgot to mention something. Back up in the original problem. Were those like terms to start with? You have to have like terms to add. You do not have to have like terms to multiply. Like terms is for adding. I can multiply anything together. So I'm going to multiply my whole numbers together. I'm going to multiply this x times this x times this x. I'm going to multiply this y times this other y, and then I have a z. Now this is not distributive because there's no adding signs in between it. 3 times 10 is 30. 30 times 2 is 60. So this is 60. X times x times x, do we know that's x to the third power? Y times y is y squared, and then a z. Last example. Because of order of operation, you multiply first, and then you add. I'm going to multiply this term and get an answer. I'm going to multiply this term to get an answer. And then I'm going to see if there's any like terms I can combine. So 4 times 5 is 20 plus 2 times 4 times x times another x. 20x squared plus 8, x times x would be an x squared. I do not have to have like terms to multiply, but I do have to have like terms to add. Do I have like terms? And so that would be 28x squared. And so you have an assignment in school